Hello, Math Humans. We're going to do 2.2 today. Today we're going to be looking at location of center. So our objectives are that we're going to calculate the mean, the median, and the mode, all three of which are measures of center. So as we get started, I just want to point out that the center of a sample, and then in parentheses I'm just going to write a population, is really important. Okay, and we use that to talk about lots of different aspects of center. So for example, when you graduate from college, let's say you plan on earning $50,000 a year, okay, and that's going to be based on research. And so research is going to show maybe for a particular type of career that you could potentially earn $50,000 a year. This is a measure of center because it is an average, okay? So you might earn a little more and you might earn a little less. And again, it's going to depend on what career choice you make. If you're going to be a heavy equipment operator, you might start your beginning salary at $100 an hour. Oops, that's an hour. And again, this could be a measure of center. It is a measure of what other research has shown that could potentially be something that you could make for a wage. So as we talk about center, we want to talk about a sample mean. Okay, so mean, which is a great word, means average. Okay, so mean is average, and that is the sum of the data points. So you add them all together, and we're going to divide by how many data points. And so this is when it's really helpful to have a calculator. By the way, in Chapter 2, you're really going to need that graphing calculator. So if you don't have one, you either need to get an app on your phone or you need to come into the school and get a grapher to borrow. I will tell you that the app on your phone, there are a couple of things in this particular chapter that it will not do. All right, so remember that we can talk about sample or we can talk about population. And for the majority of the time, we're going to be talking about sample, but I just wanted to show you some differences. So for the sample mean, we're going to call that X with a line over the top, and that's called X bar. And that's just going to be the sum of the data points. And I'm going to write sum meaning this way. This is the Greek letter epsilon, and all it does is mean sum. So it's shorthand for writing sum. So I'm going to sum all of my data points. So sometimes math equations look really scary, but once you understand what the Greek letter means, then it's not a big deal. By how many, and remember for a sample, that is little n. The population mean, on the other hand, is another Greek letter that looks like this, and we call that mu. And again, that's going to be the sum of the data points. And we would divide it by capital N, which is the total population. So this is going to be the one that we're going to focus on because we're talking about sample and not the whole population. The reason that I wanted to show you this is you will potentially see this when we do some work with your calculators. You'll see this in other books, and I wanted to make sure that you understood the difference between the variables. So the next variable of center that we want to talk about is median. And I think about median like when I'm driving. So if I'm driving down a road and there is a barrier in the middle so that I can't go from over here, here's my cool car. If I can't go from here to here, this is called a median. So median is a measure of center, and it means middle, okay? So in a set of data, the median is the middle. If two numbers share the middle position, then all we have to do is average those two numbers together. So if two numbers share the same position, that's okay. We just average those two numbers together. Alrighty? The last one that we want to talk about, and I'm going to try to squeeze it in down here on the bottom because I've already got your first example written out, is mode. And mode is the number that happens the most. So it's the number that occurs the most frequency. So using our good statistics words, we're going to say that it is the number with the highest frequency. And frequency, if you'll remember, means just how many times that number shows up. Alrighty, so I want to go ahead and use mean, median, and mode as we look at our first example. So in example number 1, we have the first 11 days of May 2013 in Flagstaff, yay flag, has the following high temperatures. And so here are the 11 numbers that we want to use for our particular example. All right, so we want to find, if we finish the example, the mean, the median, and the mode. Okay, so let's start with the mean. Remember that we are using a sample, so it's going to be X bar. So that is the sum of the data points divided by how many. Okay, so then what I'm going to do is I would add all of these numbers up. So I would do 71 plus 59 plus 69 plus 68 plus 63 plus 57, and then there are 4 57s, so 57 plus 57 plus, that's 3, there's the 4, then I add the 65, the 67, and I'm going to put a parentheses around that, and then I would divide that by 11, because it told us that there were 11 numbers, and then I could count to make sure. So you can do all this in one fell swoop on your calculator. So I would do 71 plus 59, 69, 68, 63, 1, 2, 3, 4, and then I have 65 and 67, close, divided by, and then that number at the bottom was 11, and I hit enter, and I got 62.73. Okay, if we round to the third decimal place, or sorry, the second decimal place. So then we would say that X bar is equal to the 62.73, and then if units are given, you have to report units. And we had our units given right there. So now what I need to do is I need to put my data in order to be able to do median. So for calculating median, I guess we're really not calculating, the data has to be ordered, meaning that you have to put it in numerical order from smallest to largest. So I'm going to rearrange. There's 57. There were 4 of those. And it's helpful when you're ordering data to just mark those off. The next number was 59, so I'm going to mark that off. And then my next one is 63, and I'm going to mark that off. And I have 65, mark that off. Then I have a 67, and a 68, and a 69, and then I have a 71. Okay, so median, remember median is the middle number. The good news on this is because we have 11 data points, it means that it's going to be exactly one number in the middle. So 1, 2, 3, 4, 5. This is the middle number, and if you want to confirm, there are 1, 2, 3, 4, 5 numbers on the left, and 1, 2, 3, 4, 5 numbers on the right. So the median is going to be 63 degrees Fahrenheit. All right, and then the last thing that we needed to calculate was mode. And remember, mode is the number that occurs the most often. And that one was really easy because I have 1, 2, 3, 4 of those. All of the rest of them are just one number. And so the mode would be 57. So that was actually really pretty easy. Okay. All right, let's do another example. This one's not pre-written out, okay, but it's a pretty short one. So for example number 2, these are a random sample of unemployment rates, which always makes us sad, unemployment rates for 10 countries in the European Union. Oops, too many E's. Euro, European Union, and we call that the EU, okay, for March of 2013. It would be interesting to know what more current data is, and I want to find the mean, the median, and then the mode, okay? All right, so the data that we're going to be given is 11.0, 7.2, 13.1, 26.7, 5.7, 9.9, 11.5, 8.1, I have two more, 4.7, and 14.5. So the first thing that I'm going to do is to put my data in order because that's what we have to do for the median. So I'm going to go ahead and do that at the beginning of the problem. So as I look at my data, this is 4.7. So I'm going to write that number first. And then I have 5.7. And then my next number is 7.2. And then my next one is 8.1. My next one is 9.9. And then my next number is 11.0. And then I have 11.5. Where'd my 11.5 go? There he is. And then I have 13.1. Okay. And then I have 14.5 and then 26.7. So in this one, I have an even number, so that means that the median is going to have to be the average of two numbers. So let's start with our mean. So remember that mean is x bar, and it's just the sum of the data divided by how many data. And so then that would mean I would add all of the numbers together. Okay, so I would add all 10 numbers. When you do that, you're going to get 112.4. We have 10 data points, and so then I get 11.24. And in case you didn't notice, these are percentages. So these would be percentages of unemployment. And yikes, that would be a scary country to have to try to find a job in. So my X bar is 11.24% unemployment. And so even though there really aren't units given, we know what that number represents. So now let's look at our median. And remember, median is the middle number. Okay, so if I count from my data, here's the first one, second one, third, fourth. These are going to be my two middle numbers. So I'm going to average those two together. So I'm going to do 9.9 plus 11.0, and I'm going to divide by 2, and I get 10.45. So the median is going to be 10.45% unemployment. Okay, and then the mode would be the last number. So for my mode, remember that's the most often. Okay, but if you'll notice on our data, none of the numbers are repeated. They're all single standalone numbers. So we would say that there's no mode, okay? So one of the really interesting things about mean, median, and mode is which one is going to be the most reasonable depending on what type of prediction I'm trying to make. So we saw that the average was 11.24%, and we saw that the middle number is 10.45%. So the interesting thing to look at with our data is these are both measures of center. Mode is also a measure of center, and there is no mode, right? So for the mean and the median, the conversation could be different. But let's look at this number right here. That number is significantly different than all of the other data points, and so it's possible that that number is an outlier, okay? So let's see what would happen to the mean and the median if we took that number out. So I'm going to redo our calculation. I'm just going to rewrite our numbers real quick. So we have 4.7, 5.7, 7.2, 8.1, 9.9, 11.0, 11.5, 13.1, 14.5. And we removed the outlier. So let's see what happens. I guess it helps if you can see that. Let's see what happens to the mean. So for our x bar, that would mean that we would add all of those numbers together. Remember, we removed one, so that means that n is 9 this time. So I'm going to have 4.7 plus 5.7 plus 7.2, 8.1, 9.9, 11.0, 11.5, 13.1, and then my 14.5. And I'm just going to go ahead and hit enter just so we can see the difference in numbers. So I have 85.7. We had 10. We took 1 away. So now I'm going to divide by 9. So then my 85.7 divided by 9. And now I get 9.52%. So my X bar is 9.52% unemployment. And we'll talk about what it was. It was, before we took out the outlier, it was 11.24% unemployment, okay? And then now let's look at the median. Let me get my handy-dandy other pen. So my median, okay, remember, so now I have this one, and then this one, this one, this one. Now I only have one number because I have an odd number. So my median is going to be 9.9% unemployment. And it was 10.45%. So of the two numbers, mean was more affected by removing the outliers. So important to notice is that the mean was more affected by removing the outlier. So it's an interesting thing to notice, and that's what we were talking about with our original data, is when we are comparing locations of center, we have to be careful if we have outliers. The mean is always going to be more affected by taking away an outlier. And so maybe if we looked at our data originally, and we had that 26.7% of unemployment, that's a huge number, right? That means more than a quarter of the population is unemployed, okay? Alrighty, so just to note that important fact that the mean is more affected by the outlier. Alrighty, so I want to go back for our last example and talk about our Pepsi and Coke numbers that we had done before. So this is our example number 3, and I want to go back to our Pepsi and our Coke and our Dr. Pepper example that we did a couple of days ago. This was qualitative data. Remember, that was a preference instead of maybe an unemployment rate. So the only average that we can use, the only measure of center, hang on, as I bring my calculator or my computer back to life, the only average that we can find is mode. Because I can't take an average because it was you can't take an average of opinion. That's a little bit weird. So the only average that's really effective in qualitative data, important to notice, is the mode. And so we had, if you'll remember, Coke, we had 9, Pepsi, we had 10, Mountain Dew, we had 5, Dr. Pepper was 5, and Sprite was 4. And so Pepsi had the highest frequency. So therefore, our mode would have been 10, okay? Because we had Pepsi is the one that occurred the most often. So what would have happened if one more person came in and chose Coke? So what if, okay, so one of those lovely what if questions, one more person chose Coke. Well, then that means if we look at our data, that means that we would have had 10 people choosing Coke, and then Pepsi would have 10 people. And so this is a unique situation called bimodal, which just means that there are 2 modes. And so when we would record our information, we would say that the mode is both Pepsi and Coke. Alrighty, that is it for today. Thank you for being patient, and I will see you soon.